Okay, YouTube, my last two videos, we've been writing linear equations using slope-intercept form, where we know both the slope and the intercept for a given situation. In this situation, we're going to read through, we're going to have both a slope but a point on the graph. We're not actually going to know the y-intercept, but we still wish to write the equation of a line that represents a given situation. So let's go ahead and take a look at how we might set up a couple of linear equations from a given situation and use what we call point slope form in order to do so. So looking at the situation, it says Kelly and Kim are both babysitters, and we're told Kelly charges a flat fee of $10 right off the bat, plus $6 per hour to babysit. Okay, so we're given that essential information here. It says the table shows the total hourly fee that Kim charges to babysit. So we can see her data is actually presented in a table over here, and we notice that her first hour is $22, but after that it's just going up by 4 every time. Okay, so plus 4, plus 4, plus 4. So the questions are here. We say who charges more per hour, and how many hours must Kim and Kelly babysit for the total fees to be the same? So I'm going to come back to those questions. What I want to start with is essentially this. We need to understand this problem. So we're given a verbal explanation of Kelly's fees, but a table that represents Kim's fees. We need to compare the costs. So right off the bat, when I get asked this question, it says, okay, who charges more per hour? I'm kind of inclined to say that, I think Kelly does because she charges $6 per hour, whereas it seems to me that Kim's fees are only changing $4 every hour. So we would say, okay, well, I understand that, Kelly charges more per hour. I'm going to write that down. Kelly has the higher, I'm going to write it this way, hourly rate by $2 per hour, okay? Step 2, though, we want to make a plan, okay? So it says we'll want to write equations that represent both Kelly's and Kim's fees, and we'll let their fees be represented by y and dollars over time, x, and we'll let x be represented with hours, okay? It says then compare the slopes to determine which young lady charges more per hour. Well, we've kind of already determined just using intuition here who charges more per hour. But if we had the equations of lines, then we could literally see who charges more per hour because we would compare their slopes. Remember, slope is the rate at which a line is changing. It says finally what we'll do is we'll equate the cost expressions and solve to determine the number of hours each of them will have to work in order to charge the same amount. So the second question really was this: how many hours do Kim and Kelly have to babysit for the total fees to be the same? So how many hours? In other words, go find x. But find x such that their costs are the same. Remember, we're representing costs or fees with y. So what we're really saying here is this: if I had an equation for, let's say, Kim's equation, and then we had y, Kelly's equation, and they were each expressed in terms of some x, okay? What we could do is we could just basically set equal the two costs and say, well, then let's go find out what x would have to be in order to make that equal. So in order to do this, we have to have equations of lines. So what do we know about writing the equations of lines? Well, we need a slope. So step 3, when I say solve the problem, the first thing you'll notice I say here is this: find the slope of the graph for Kelly's charges from the verbal explanation. So we would say, in terms of Kelly, let's go ahead and write down her information. We know that her slope is $6 per hour, okay? That's her rate of change. I say also find the slope for the graph of Kim's charges by using any 2 points in the table. So I guess what I'm saying here is we have a couple of xy pairs. It certainly doesn't matter which ones we pick, but let's say we have x1, y1 is 1, 22, and x2, y2 is 2, 26. What we could do is we could say, well, as far as Kim is concerned, the slope, or her rate of change, is going to be equal to y2 minus y1. So we have 26 minus 22, and that's over 2 minus 1. So we get this, we get 4 over 1, or in other words, we get $4 per hour. So we have the slope for both of these given situations, okay? So what we want to do now is use that slope to write equations for both young ladies' costs, and use the slopes that we found and either the y-intercept, if we know it, or any point xy on the graph to write that equation. So as I mentioned at the beginning of this video, this is the first time where I don't know how much, Kim charges at 0 hours at the very, very beginning. And I certainly don't know how much Kelly charges for 0 hours. As a matter of fact, I hope they both charge nothing. But in terms of a mathematical model, we don't know their y-intercepts. So what we're going to need to do here is we're going to need to use a point and a slope. Now I'm going to rewrite this formula here. I'm going to overwrite on top of this, or right over the top of it. We have y minus y1 equals slope m times x minus x1, where what we needed was a point x1, y1, so we can plug those values into here, and we need the slope m. So when it comes down to writing Kelly's equation here, it's very easy to do because all we have to do, actually, we do know her y-intercept here. She charges an initial 10 plus $6 per hour. So I suppose Kelly's line would be equal to $6 times the number of hours plus 10. The one that we need to use the point slope form on, though, since we don't know the y-intercept, is Kim's babysitter's fee up here. So we say, well, to do this, we're going to use point slope form. And here's how point slope form works. We say y minus the y value of some point on the table or on the line is equal to m times x minus some value x1 that we're plugging in. So what I'm going to do is I'm going to pick one of these data values up here. And I'm actually going to pick the point 1, 22 because I know that's on the graph. So I'd say, well, I'm going to plug in 22 for y1 because that's our y value of our point. I'm going to plug in 1 for our x1 here. And our slope for Kim, at least we were able to determine from the table here, is that it's going up by 4. We also use our slope formula, so we say 4. So as far as writing the equation of her line, it is very appropriate to do this. We say y minus 22 is equal to 4x minus 4 after we distribute. And I'm going to add 22 to both sides here. I'm going to add that constant to both sides. So what we get here is a new equation that represents her cost over time, where we have 4x, where 4 is our slope. We say negative 4 plus 22, that is 18. So we have Kim's equation now, and we have Kelly's equation. Okay, so in terms of which one charges more per hour, again, I notice here that the slope for Kelly is a little bit higher than the slope for Kim. Okay, it's 1.5 times the size, $2 more per hour. So what we want to do last is equate the cost expression and solve for the number of hours that makes them equal. In other words, like I mentioned up here, if we have two equations and we want to find out, well, how many hours would they have to both work before they charge the exact same amount? What we'll do is we'll take the y values and we'll say, let's set their costs equal to one another. So we're going to equate the two y's. And if we're going to equate the two y's, essentially what we're saying is, well, I have a y expression here, and that's equal to 6x plus 10. That's what hers is. And we say, okay, equal to, now let's head over here. We say, I know what y is here. We'll go plug this in. We get 4x plus 18. So all we really need to do at this point is solve for x. So the appropriate way to do this would be to usually take the smaller value of the two x's and kick it over to the other side. So what this implies is essentially 6x minus 4x is 2x plus 10. That's equal to 18. So now we'll subtract 10 from both sides. And we get 2x is equal to 8. So if we divide now both of these expressions by 2, we get final implication here is that x is equal to 4. And I'm going to label this since it's an application problem. But we say it would take 4 hours for them, to both charge the same amount as one another.